Hello, Year 11. In this lesson, we're going to focus on vectors and proof. Our inquiry question is how can we use vector notation to identify the properties of shapes? Slides 2, 3, and 4 contains answers to the previous tasks which were provided last lesson. Please ensure you mark them. The 5 for 5 is in slide 6. Press pause and attempt the questions on a piece of paper or in your exercise book. Here are the answers. They're on slide 7 for your reference. Two vectors are parallel if they share a common factor. For example, 4a and 7a are parallel because a is the common factor. Also, 4n minus 2n and 6n m minus 3n are parallel, as 2m minus n is a common factor. We can factorize it, algebraic expression, taking 2 out, which gives us 2m minus n. Similarly, factorizing it, take the highest common factor, 3, would give us 2m minus n. They are parallel to each other because they have a common factor, which is 2m minus n. Also, two vectors are on a straight line if they are parallel and share a common vertex. For example, R to Q is 4a and R to S is 7a are parallel as a is a common factor and they share a common vertex R, so they are on a straight line. So QRS would be on a straight line. Now, there are two types of questions, two types of vector proof questions you would actually see. The first type is proving two vectors are equal to each other. And also, the second type is showing that they are parallel to. And the last one is proving that it's a straight line. There are three types. First type is proving that two vectors are equal. Show that the one vector is parallel to another vector, and proving two vectors are on a straight line. Now let's look at a first example showing vectors are equal. First question, express A to B in terms of A and B. Now I've noticed people just writing down the final answer. It's okay for a 1 mark question. However, for 2 or more, we have to list the steps clearly. A to B, A to B. We could follow the route A to O and O to B. And we know A to O is opposite to 3A, so that would be minus 3A plus 6B. Either we could write minus 3A plus 6B or 6B minus 3A, and they're both equivalent to each other. X is a point on AB such that A to X and X to B is the ratio 1 to 2. Now, I suggest you start writing them as fractions, which would help you. So A to X is 1 and this is 2 parts. So that will be as a fraction 1/3 of the entire entire line, and x to b would be 2/3 of AB. So AX is 1/3 of AB and XB is 2/3 of AB. Now, since we know AB, it's easier for us to now solve the question. Now, it's asked, prove O to X is 2/5 of OY. O to Y. I'm going to start with the O to Y. And the O to Y, we could work it out as O to B and B to Y. And we know O 2/5 of OY, 2/5 times, as I mentioned, O to B, which is 6B, plus 5A minus B. Simplifying it would give us 5A plus 5B, and 2/5 of 5A plus 5B is 2A plus 2B. Now, let's see how we can calculate O to X. We calculated what's 2/5 of OY. We're trying to find out what's O to X would be. It should be O to X. And we could follow O to B and then B to X, or O to A plus A to X. I'm going to use this route, O to A plus A to X. O to A is 3A plus, we know A to X is 1/3 of AB. So that will be 1/3 of AB, which is minus 3A plus 6B. So that's 1/3 of AB vector. Would give us 3A plus 1/3 of minus 3A plus 6B, which would be minus A plus 2B. Simplifying it would give us 2A plus 2B. As both of them results in 2A plus 2B, therefore OX vector is equal to 2/5 of OY vector. Remember, questions involving proving, identify the value of the left-hand side as well as the right-hand side, and they should both be equal to each other. Using this as an example, please attempt the questions in slide 12 onwards. Now let's look at another example. B is a midpoint of AC. M is a midpoint of PB. Find P to B in terms of A and B. They want to find out what's B to B. We know B is a midpoint of AC, so B to C will also be vector A. So P to B would be minus B minus 2B plus A, which would result in minus 3B plus A. Notice the B's are negative because we're going in the opposite direction. Now, the next question would be show that the NMC is a straight line. So N to M to C. I do apologize. I'm just using the mouse to draw them. You could use a straight line and to draw them. So we need to prove NMC is a straight line. So firstly, what we do is we find N to M vector. And then we calculate n to c vector. Firstly, n to m. N to m could use n to p, which is b vector b, plus half of pb. And we've already calculated pb earlier, which is minus 3b plus a, or a minus 3b. Expanding them and simplifying it would give us half a minus half b, which is half. We can factorize a minus b. Now let's see how we can do n to c. N to c vector would be n to a plus a to c. N to a is minus 2b, and the a to c, which will be added to a. Rearranging and factorizing will give you 2 brackets a minus b. Notice they have a common factor a minus b, and the n is a common point. Hence, NMC is a straight line. Now you need to open the worksheet vector proof. You need to type in the working out clearly and then solve them, the questions. Do ask me if you have any questions. Good luck.